Hello everyone. What I'd like to do in the lecture today is talk about complex fractions. And what a complex fraction is a fraction within a fraction. We all know that A over B divided by a fraction C over D is the same thing as saying A over B divided by C over D. And the way to divide fractions is to invert and multiply. We know that as keep, change, flip. So on this first situation, if you have A over B divided by C over D, you would change that to keep the first fraction, change division to multiplication, and flip the second fraction, which turns into AD over BC. Well, on the other hand, if you have A over B divided by C over D, we do the same thing. We keep the top fraction as A over B, we change the fraction bar, which is division, to multiplication, and we flip the bottom fraction, D over C, okay, which again would give us AD over BC. So if we need to, first of all, evaluate this 2 minus x over x plus 1 rational expression with x equals to 2/3, I'm going to substitute. So it's going to be 2 minus 2/3 divided by 2/3 plus 1. Now to simplify this expression, what we need to focus on is I need to get the numerator down to one number. I need to subtract 2/3 from 2. I need to get the denominator to a single value. I'm going to add 2/3 plus 1. Well, folks, to do this, you know we need a common denominator, right? So what I'm going to do is I'm going to multiply this 2 that's really over 1 times 3 over 3 so that we have a common denominator. And that's going to give me 6/3 minus 2/3, which is good. I'm going to keep working straight across. 6/3 minus 2/3 we know is 4/3. And in the denominator, I'm going to do something very similar. This 1 is over 1. I need it to be over 3, so I have a common denominator, so I multiply by 3 over 3, which is going to result in 2/3 plus 3/3, which gives me 5/3. Now I have a situation just like we did here. This is A over B divided by C over D, so I'm going to keep the 4/3. I'm going to change this fraction bar to multiplication, and I'm going to flip 5/3, make it 3/5. Now, conveniently, we can cancel this 3's because you can cancel a numerator and a denominator when you're multiplying, and we get 4/5 as our final answer. Now, over here, in red, I'll do this one in red, our numerator on question B is already a single fraction. Our denominator is already a single fraction, so B is an easier problem than really our complex fraction that we had on question A. I'm going to keep the 3 over xy squared. I'm going to change my division bar to multiplication, and I'm going to flip my denominator fraction to x squared y over 15. And then I'm going to treat this like I would in a previous section when I multiplied fractions. So what I do know here is that I can cancel this x with one of those x's, this y with one of those y's, and 3 divides into both 3 and 15, so 3 divides into 3 once, 3 divides into 15 5 times. And then let's write what we have left. In the numerator, I have 1 times, there's still an x right here, okay? So 1 times x is x, and in the denominator, there's still a y right here, times 5 is 5y. And that is my final answer on that problem. Next problem is, again, we have a complex fraction. How do I know? Because you have a fraction inside another fraction. Now, the problems are simpler when you have a single fraction in the numerator, which we do, and a single fraction in the denominator, which we do, okay? Because then it's time to keep, change, flip. I can keep the 3 divided by x minus y. I can change my fraction bar to multiplication, and I can flip my denominator fraction and turn that into 3 over x minus y, okay? So again, we flip this guy right here. Now I'm ready to multiply. Nothing cancels. 3 times 3 is 9 over x minus y times x minus y. I can write it as x minus y squared, or I can write it as 9 over x minus y times x minus y. And what I don't have to do is I don't have to distribute this denominator. I don't have to use the FOIL method there. It is just fine, completely factored. The next problem, D, is very similar. Notice I have a single fraction in the numerator. I'm going to keep 5 over x plus y. I'm going to change this division bar right here to multiplication, and I'm going to flip the denominator. Okay, so I have 5 over x plus y. That's my keep on top. Change division to multiplication, and I'm going to flip x minus y over 5. Now in this situation, my 5's do cancel because they are common factors, one in the numerator, one in the denominator. But now my x minus y that's in the numerator over my x plus y in the denominator does not simplify further. That's as far as that will go, because you can't cancel this x and this x because that's part of a sum and part of a difference. Remember, we can only cancel things that are being multiplied together that match, like the 5's. Next problem. Now this one's a little more involved, and I know you see why. In the numerator here we do not have a single fraction. We do have a single fraction in the denominator. 9a squared minus 1 over 3a is one fraction. But in the numerator, these are like two separate fractions here. So I'm going to have to find a common denominator for the top and then combine like terms. So we imagine this a is over 1 minus 1/3 divided by my fraction, my single fraction in the denominator, which is 9a squared minus 1 over 3a. So I need to find a common denominator and combine these two fractions in the numerator together. To do that, I need to multiply by 3 over 3. So I have a common 3. All right. And then when I simplify that, 3 times a is 3a over 3 minus 1 over 3. And I'm rewriting the denominator again. Okay, now that these have a common denominator, I can rewrite that as 3a minus 1 over the common 3. Now, why don't we go ahead and flip here? And again, we can do that because it's a single fraction. I could not flip in the numerator, even if I had to. I don't need to flip in the numerator, but I could not do anything with the numerator as two separate fractions like it was. So I'm going to flip 9a squared minus 1 over 3a times and make it 3a over 9a squared minus 1. The 3's cancel, so that simplifies into a times 3a minus 1 over 9a squared minus 1. Now your thought there is we'd be finished, but there's something I want you to notice. This is a difference of squares right here. This will factor, and you should always attempt to factor just in case there are common factors. So I'm rewriting the numerator, which is factored. And in the denominator, that's a difference of squares. So the square root of 9a squared is 3a. That goes in the first position. The square root of 1 is 1. Goes in the second position with 1 plus and 1 minus. And the 3a minus 1's cancel to result in a final answer of a over 3a plus 1. Our next example, very similar. I need to combine these fractions in the numerator, but I also have to combine fractions in the denominator. So I'm going to rewrite the numerator as x over 1 plus 2 over x squared, and the denominator 1 over x plus 2 over 1. Anytime you have a whole number, put it over 1, and that'll help you see better what's going on. In the numerator, my common denominator is x squared. So I'm going to multiply x over 1 times x squared over x squared. That way we have a common denominator. That's going to result in x to the third plus 2 over that common x squared. You see that? So this is my x to the third. Of course, the plus 2 is from the second fraction, and I went ahead and write it as one fraction over x squared. In the denominator, my common denominator is x. So there's already an x here. I need to multiply this fraction by x over x. That's going to result in, so big fraction bar, 1 plus 2x over my common x. So now if you'll notice, I have a single fraction in the numerator and a single fraction in the denominator, which means I am ready to keep change flip. So I have x to the third plus 2 over x squared. I'm going to change division to multiplication, and I'm going to flip x over 1 plus 2x. Now I can cancel common factors. This x cancels with one of those, and I result in x to the third plus 2 over x times 1 plus 2x. And I am completely simplified. So our next problem, again, I think it's important to write your whole numbers or your whole variables over 1, x over 1 minus 3 over y squared, and divided by 2 over x minus 3 over y squared. So I'm going to find a common denominator in the numerator and separately in the denominator so I can combine these together. In the numerator, a common denominator is y squared, so I'm going to multiply by y squared over y squared. And the denominator, my common denominator, is xy squared. So this first fraction is missing a y squared, and the second fraction is missing an x. Okay, did you follow that? Again, common denominator, the numerator is y squared, because 1 times y squared is y squared. So I'll multiply by y squared over y squared here, because that's missing. Here, it's the combination of these two multiplied together. This is missing the x, that's missing the y squared. So let's simplify and see what we have. Alright, so I have xy squared here minus 3 over y squared. Okay, big fraction bar, which is the original fraction bar. Here I have 2y squared minus 3x over my common denominator with xy squared. So now notice I do have a single fraction divided by another single fraction, so it's time to keep change flip. So I'm going to keep my numerator the way it is. So xy squared minus 3 over y squared. I'm going to change my division bar to multiplication, and I'm going to flip my denominator, and now it's going to be xy squared as my numerator, and 2y squared minus 3x is my denominator of my big denominator fraction. Alright, now this y squared cancels with this y squared because those are common factors. I don't see that I can cancel anything else because this is not factored. Okay, so xy squared is a term, minus 3 is another term. Same thing down here, 2y squared is a term, minus 3x is another term. There are nothing common I can cancel there. So xy squared minus 3 over 2y squared minus 3x. Okay, again, it's very important for you to understand why you can't cancel, say, this y squared and this y squared, because that's part of a sum or a difference. The only time you can cancel is when you're multiplying common factors, like this is multiplication, all that's multiplication, this is multiplication, and so this y squared cancels with this one because it's not part of a sum or difference. Alright, now h over here, I consider that maybe one of the easier problems. You see why? Because it's a single fraction in the numerator and a single fraction in the denominator, so I'm ready to keep change flip. I have 12 over x squared minus 4x minus 20 times, I flip x minus 5 over 4. Now it's a matter of simplifying. Now I do notice right off the bat the 12 and the 4 will cancel. But I can't cancel like part of this x minus 5. It's either all or none. And this is not even factored. So let's factor. So I have 12 over what multiplies to be negative 20 and adds to be negative 4. I think we all know that's x. Or do we? Multiplies to be 20. That's 4 and 5, but that doesn't add to be negative 4. 2 and 10, but that doesn't add to be negative 4. How about that doesn't factor? Makes me wonder if I made a mistake when I typed out the problem. Feels like I wanted it to factor, so x squared minus x minus 20 would have worked better, but guess what? It doesn't factor. So all we can do is leave it the way it is, minus 4x minus 20, and this 12 and this 4 are going to cancel because 4 goes into 12 3 times, 4 goes into 4 1 time, and so I'm going to erase, because this step that I wrote I don't need because I can't factor. And let's write what we have, okay? So now it's a 3, and this is x minus 5, and that's a 1. So I'm going to write my answer as 3 times x minus 5 over x squared minus 4x minus 20. And that's as good as it gets. Now I would have made that problem much better if that minus 4 right there was a minus x and not a minus 4x, and then it would have factored. And then I could have canceled x minus 5s. But that's either a typo on my part or, you know, maybe that's what the original problem was. I copy these out of books often. Alright, so I have 2 problems here for you to wrap it up. So you've got the idea is you have to have a single fraction in the numerator, in the big numerator of our complex fraction, and a single fraction in the denominator. And we don't have that in either situation. So I'm going to rewrite my problem as 3 over 1, so it's a little easier to see, minus 3 over x plus 2, divided by 1 over x plus 2 plus x over 3. Now my goal is to find common denominators so I can combine this numerator together. And the common denominator is x plus 2, which means I need to multiply my first fraction by x plus 2 over x plus 2. Now let's take a look at the big denominator here, okay, and find a common denominator for it. So the common denominator here is 3 times x plus 2. So if I look at my first fraction, it's missing a 3, so I need to multiply by 3 over 3. A second fraction is missing an x plus 2, so I need to multiply by x plus 2 over x plus 2. That way they have the same denominator. Okay? Now, I'm going to simplify all of this. So right here, this 3 times x plus 2, so 3 times x plus 2 is going to be 3x plus 6 minus, we didn't multiply this second fraction times anything, so minus 3 over our common denominator, which is x plus 2. So that handles the numerator for the moment. In the big denominator, I have this 1 times 3 is 3 plus, now here I'm going to distribute, just like I did up here, x times x is x squared, x times 2 is plus 2x, and over that common denominator, which is 3 times x plus 2. Now I need to distribute denominators. We distribute numerators, not denominators. Alright, so now I continue. 3x plus 6 minus 3, I can combine like terms right here. It's going to be 3x plus 3 over x plus 2 divided by denominator. There are no like terms down here, but I am going to change the order. X squared plus 2x plus 3 over, keep that denominator factor, 3 times x plus 2. Now it's time to keep, change, flip. Okay, so I have 3x plus 3 over x plus 2 times 3 times x plus 2 over, now that's x squared plus 2x plus 3. Y'all, that'll factor. Multiplies to be 3, adds to be 2. No, it won't. Multiplies to be 3 is just 1 and 3, but that adds to be 4, doesn't it? So it's not going to factor. Leave it as x squared plus 2x plus 3. Now this x plus 2 cancels with this one. And now my answer is I have this 3 times 3x plus 3. I haven't multiplied that out yet. Over x squared plus 2x plus 3. This is, to me, a perfectly suitable answer. It's fine. But you could distribute the 3 inside and say that is 9x plus 9 over x squared plus 2x plus 3. That's okay as well. Alright, so keep in mind, both of these are right. There's nothing wrong with either of these answers. Now for our very last problem, let's take a look at this. Notice we have in the numerator, in the big numerator, we have 2 separate fractions. And in the denominator, I just have a 2. Okay, so my first thing is I have to combine these together, but I can't because I don't have a common denominator. So the very first step is going to be to find a common denominator. Well, the common denominator is going to be h plus 1 times h minus 1. There are no common factors there. So I'm going to rewrite my problem, h over h plus 1 with some room minus h over h minus 1. And remember, that's all over 2. Don't want to forget about that 2. Now, here's I'm trying to find a common denominator. Well, we know what it is, h plus 1 times h minus 1. So this one's missing the h minus 1. So I'm going to multiply by h minus 1 over h minus 1. This one's missing the h plus 1. Okay. And to simplify, remember, you do not have to multiply out denominators, but you do have to multiply out numerators. So h times h is h squared. H times negative 1 is minus h. Now this is minus all of this. So y'all, what I'm going to do is I'm going to consider that this is a negative h. So negative h times h is negative h squared. And negative h times 1 will be minus h. That's all over my common denominator of h plus 1 times h minus 1. And don't forget, that's still all living over 2. Now h squared cancels with h squared. But negative h minus h is negative 2h over h plus 1 times h minus 1. That's divided by 2. Y'all, that 2 is really over 1, so I can keep, change, flip. Okay, so I'm keeping negative 2h over h plus 1 times h minus 1. I'm flipping 1 over 2. Turns out this 2 cancels with this 2. So my final answer is negative h over h plus 1 times h minus 1. Final answer there. And it was a little congested. But again, negative h over h plus 1 times h minus 1. Hope this helps. Remember, the overall goal is to get your big numerator to one fraction by finding a common denominator and adding it or subtracting. Get your big denominator, like this, as one fraction. Again, common denominator. And finally, when you have a single fraction over another single fraction, you keep, change, flip, factor, and cancel, and you're finished. Have a great day.